Again, welcome you to here this morning. You know who I am. I'd like to know who you are. If the following descriptions at all apply to you, I'd like you to stand. How many here are facility managers or facility-related professionals? Maintenance personnel specifically? Excellent. How about contracting people? Service providers? Excellent. Any others that I'm missing? Who didn't stand? Okay, good. All right. We have a few different learning objectives. Those are measured, by the way, in those 4 true and false questions that I'll review with you at the end of the presentation. But I will discuss with you a few different ways in which building automation can contribute to your sustainability goals. And you should be able to enumerate those. There's just 4 of them. I'd like you also to describe how building automation can contribute specifically to higher energy efficiency, which is one of those 4. And then, because I'm representing BACnet International, I'd like you to tell me why a BACnet system is more sustainable than alternate systems. And I'll review that with you as we proceed. All right. Oh, the buttons are backwards. I'm holding it upside down. That works better. You know, we're on a collision course here, folks, with sustainability. You might be welcoming that. You might be a little resistant to that, but we are on a collision course. And I'll tell you how to prepare for that collision course through some building automation techniques today. Let's talk about some definitions. I'll use the term building automation system, by the way, or systems, and that refers to, as indicated here, this internetworked collection of hardware and software. It's monitoring, it's controlling various pieces of equipment, various processes in your facility. And by the way, I'm restricting that term use to commercial or institutional, industrial type facilities as opposed to anything residential. We do use the term home automation in the residential arena, by the way. These can be installed in new buildings as part of a retrofit, and they're there to help you. And I'll enumerate some ways that they do so as we proceed. Typically, you will not see a great deal of an automation system in your facility. That is, there are parts and pieces that are connected to equipment. There are parts and pieces hidden in the ceiling or in mechanical rooms. You might interface with sensor-type devices or thermostat-type devices or an operator workstation with a computer screen of some sort. But for the most part, a control system is operating behind the scenes. Oh, good. Yeah, this little drawing up here kind of summarizes the whole thing, if you will. You might interface with some of these type devices, but most of the control is behind the scenes, and then equipment or processes are being controlled through an automation system. Now, there are a number of related terms that you should understand, because you're going to hear a lot of these terms, and you might think, well, they're all interchangeable. And to some extent, that's true. To some extent, it's not true. The official term, by the way, this is the term used by all the market research companies, is building automation and control systems. You might hear building control system. You might hear building management system. These all typically refer to the building automation system. I've heard a new term only recently, within the last year, mostly out of your community, using the term building operating system. You're recognizing the increasingly important connection to the IT infrastructure of your building. So it's the IP connectivity, and it's the interactions with the IT staff that are driving your definitions of what companies like mine provide. When we use the term controls, by the way, we're talking about discrete devices used within an automation system. A direct digital control refers to the communication method, a digital communication method. You might also use the term energy management system. Years and years ago, this term became popular among automation manufacturers, and we were proclaiming ourselves as the energy management system. And yeah, it's true, a great deal of what we do has to do with energy. I'll talk a great deal about energy today. But today that term really has more particular meaning to the energy-specific functions of an automation system, providing you the energy dashboards and related reports specific to energy usage. And finally, that term on the bottom there is smart or intelligent building is a building. Hey guys, there's a couple other seats right up here to help yourself. No, seriously, there's a few seats right here in the front row. And do feel free to join me up here. I get lonely. Now, we're here to talk about sustainability, so let's define that term. I'm sure you have some preconceived notions, as do I. Here's my definition. We're trying to engage in practices that lead to long-term viability. In other words, practices that provide for our needs today without sacrificing what has to happen tomorrow. The end game, I think, is a building that requires no more from its environment than what it can return to its environment. Some examples of this that you may have heard of. You might have heard the term net zero energy, or more recently, and for some, I don't know who sits back in a room and thinks of these things, but now I see the term more often, zero net energy, and it's hyphenated this time, zero net energy. So if you see the acronym ZNE, you know you're talking about net zero energy. Another example, and I'll show you a case study of this a little bit later in the presentation, is the Living Building Challenge. Yeah, you are familiar with the LEED standard, undoubtedly. Well, think of the Living Building Challenge as LEED on steroids. That's really what it's all about. Why would you choose to pursue a sustainable course for your facility? Well, you might feel some professional responsibility, some social inclination to do so. That's a legitimate reason. You might also have some stewardship responsibilities for your environment and feel those intently. You might be pursuing some kind of a green building certification such as LEED or EPA Energy Star, etc. There are numerous regulatory mandates taking place that are pushing you in this direction, whether you want to or not. And now these are typically geographically centered, as particular to cities or states, but they are growing. This trend is increasing. We see from New York to Chicago, and it doesn't have to be California, by the way, mandates that are requiring public records of energy usage for any facility over 50,000 square feet. That has been true in New York City. It's now true in Chicago. And these mandates are forcing you to report your energy usage. Now, what's the end game there? Obviously, they want you to manage that energy and reduce that energy. So a lot of mandates out there. You might be swept away by the promise of cost savings for your sustainable plans, and that's also a legitimate reason. And finally, it's probably not the best reason, but there is still some image or brand warmth associated with going green or pursuing some sustainable practices, and there's nothing wrong with a little brand warmth. Take that from a marketing guy. I'll tell you that no matter what reason you have for pursuing these sustainable goals, a building automation system can contribute greatly to its achievement. I will enumerate here for you four ways or four benefits of building automation systems towards your sustainability objectives. And these categories stand out in my mind. First of all, higher energy efficiency. This is the big one, and I'll spend a fair amount of time there, but it's not the only benefit of automation in terms of sustainability. Automation systems can lower your operating and maintenance costs. They can lead to better indoor air quality, and they can lead to greater occupant comfort and productivity, all of which I think should be admirable goals for you to achieve. So if any of these four or all of these four are appealing to you in any way, an automation approach can help. Let's delve into higher energy efficiency. Now here's a guy who knows how to save energy. I'm hoping none of you follow his example in the next 40 minutes or so. First practice I'd like to talk about is a simple practice of scheduling. It sounds very simple, but you would be surprised of when it's not implemented out there. We schedule things to avoid the costs associated with unnecessary conditioning of a space or unnecessary lighting of a space. By doing so, we avoid wild swings. We can predict run times for mechanical equipment. Energy usage from the grid can be optimized, for example. And quite frankly, it levels out that demand that we have, whether it's natural gas or water or electricity. So scheduling is very important. Now, surprisingly, there are a number of particularly mechanical systems out there that remain unscheduled. There probably was a schedule at one point in time, but over time someone took over manual control of that piece of equipment or that system, and it works for them, and it's still working that way, but it's not optimally working that way. There are no hard and fast rules here, so the numbers here is simply a guesstimate based on practices and things that I've seen in the field, but generally speaking, you can save 10% or more simply by scheduling equipment. 10% energy savings simply by scheduling equipment. It's incredible. Talk about low-hanging fruit. Occupancy-based control is another very common method here for controlling your energy costs. We achieve this through occupancy sensing. There's no reason for the lighting in my office to be operating if I'm not in my office. And we can support that, by the way. You don't have to just depend on occupancy, which are typically motion or infrared type sensors in the space itself. But you can back up those occupancy sensing with your security system, with access systems, with CCTV and other systems, so that you get a true measure of what the occupancy is really like. And you're making your energy-related decisions based on that occupancy. So many of the decisions we make for buildings were done under models. Standards were created and codes put into effect based on models of what the building was supposed to do and how many people were supposed to be in the building. And if your equipment is operating in that fashion, there's a good chance you're wasting some energy and have some opportunity to optimize it. Some interesting things going on here in terms of occupancy-based control. First of all, lighting is the most common, but you can tie lighting to HVAC, security systems, also more and more common. I've watched control system installations for a number of years, and traditionally these control systems started out strictly in the mechanical realm, the HVAC and related mechanical systems. Today, 25%, a quarter of all control installations are at least integrating that mechanical system with at least one other system, usually lighting. And more systems are being integrated all the time. We also see examples of this adaptive occupancy. There are patented technologies out there where there still are occupancy sensors, but they are actually learning the behavior. So if you have a law firm that is working late into the evening, these sensors can learn that behavior and again set schedules and set points accordingly. So you combine your scheduling, combine your occupancy, and you get the best possible results. Here are a couple other miscellaneous things. We hear a lot about chilled beam, particularly in Europe, and it is making a foothold here in the States as well. So these advanced methods, there are some advanced, even venerable techniques such as VAV have some advanced things taking place, and you need to be aware of that. Your controls solution provider, by the way, your contracting partner, can help you understand what some of those things are. There's a particular method here that you should be aware of, and we're seeing a great deal of usage of variable frequency drives today, and if you tie those drives to the supply air fans, you can maintain the proper static pressure, and proper static pressure leads to better energy efficiency. The other thing that I want you to really pull out of this sentence is this word dynamic. Your building is a dynamic environment. And if you can reset your set points to optimum set points based on that dynamic load as it changes in the facility, you'll be much better off. So I give you some indication there of some things that are susceptible to that. The airstream temperatures, supply water temperatures, cooling tower, condensing temperatures, all can be optimized based on the dynamic load of your building. Lighting controls, of course, and I don't want to dwell on that. There are sessions here at the conference particular to lighting controls, but the object here is to reduce the use of unnecessary artificial lighting. And we'll talk a little bit more about that a little bit later with some daylight harvesting, and I'll tell you what that's all about. We see control systems used in rainwater harvesting, landscape irrigation, all intended to provide all of the building's energy usage into one central location and one dashboard so that you get a comprehensive view of how you are using your energy. Now, for each of these sections, higher energy efficiency being the first one, I've provided you a hyperlink to a case study here on the BACnet International website. We do not have web access here in the rooms, so I've summarized those in subsequent slides. But that hyperlink is for your benefit later. You can go online, read the full story. This first one that I want to talk about in relation to energy efficiency is known as the Headway Technologies building of TDK Corporation. This one is located in Milpitas, Silicon Valley, California. It's 115,000 square feet, and we're talking in particular now about an energy retrofit that was completed just late last year, so this is fairly new information. Now here's the business of this facility. 115,000 square foot technology manufacturer producing, if you've ever torn apart, I don't know if any of you are geeks like me, but I've torn apart a hard drive before, and if you have, you've seen this, seen these kind of things that they produce. They are manufacturing what are known as aluminum titanium carbide wafers that are used in the read-write heads of computer hard drives, and TDK sales accommodate 1/3 of all such sales worldwide. They have two facilities, this one in Silicon Valley and another one in Japan, producing the same product line. They are an ISO 14001, have a registered quality system to ISO 14001, and they use Class 100 clean rooms. TDK is a Japanese-based corporation, and I can tell you that I know some companies in America throw around terms like continuous improvement somewhat frivolously. The Japanese do not. When they use the term, they mean it very sincerely. So they have annual energy use reduction goals. Now, those goals are dictated by the manufacturing requirements. For example, if they are projecting growth and producing this many more units than they did the previous year, they know that they're going to use more energy, but the proportion of that energy they want to be lower every year. And they're setting these goals aggressively, and they are aggressively pursuing them. Now, the other thing to keep in mind about Headway is it's located in Silicon Valley. You know, I'm a manufacturer myself located in Indiana. That's a good place to manufacture. Silicon Valley is not the most manufacturing-friendly environment in which to manufacture. A lot of regulations and standards to be upheld, expectations of the local community. So despite that pressure, despite the pressure of continuous improvement, their location in Silicon Valley, they had achieved 5 years in a row, year over year, energy reductions. Here's the caveat, however. They had done that by doing all the low-hanging fruit, all through what what was deemed internally to be the best thing to do. They maximized their internal knowledge. The facility manager here is a guy by the name of Dan Burris. He's a very astute fellow, and he had a fair amount of experience in mechanical systems and lighting systems and other things. So he had optimized over a 5-year period everything that he knew that he could do to save energy and had achieved their goals. So now the question becomes, what do they do next year? Here's the challenge. They had to achieve a 10% energy reduction goal. They had to do it without harming the production process. Now, Dan, as the facility manager, calls it his cardinal rule. Thou shalt not hurt the fab or the fabrication. They cannot shut down production. It's a 24/7 operation. This production facility is made up of clean rooms in which a number of machines or tools are producing these products. There's a plate on top of each of these machines. It takes 12 hours, start to finish a single product. That's the cycle time for a product. There's a plate of these products on each of these machines being produced over a 12-hour period. And they have to maintain a very strict environment, 68 degrees plus or minus 1 degree, 45% relative humidity plus or minus 2.5%. If any of those variables go out of spec, and any portion of that 12-hour, they're throwing out all of that product. Each one of those plates on a number of machines in each one of those rooms is worth about the price of a high-end BMW vehicle. So you get the idea of how valuable the production is and how critical it is that the mechanical systems remain in spec. So that's the challenge. And they had to do this now. They had to it's easy to maintain, but now they had to maintain while reducing their energy. That was the challenge. They started with the help of an outside contractor. They started with a very deep energy audit. Now, there are superficial energy audits and there are deep energy audits. So they did a very deep energy audit and really started thinking about systems. You know, it's easy from a mechanical or lighting or plumbing perspective to start looking at your building in terms of discrete pieces of equipment. But when you start to think systematically about the building, you get a much more comprehensive view. One of the significant revelations that the contractor came up with was, you're conditioning 100% of your air. Some of that air has already been conditioned, and it's being returned through the return system. And you're adding makeup air, yes, and you're adding fresh air from the outside that, yes, has to be conditioned, but you don't have to condition all of the air. So they added a lot of sensors and started conditioning only the makeup air and of course the supply air. For water usage, they added the variable frequency drives. They staged various pieces of equipment, stop times. They added sensors, a lot of backnet control, maintaining pipe pressures, very important because they're using water for gas, they're using water and steam and domestic hot water usage for production purposes. So maintaining proper pipe pressures saves energy. ROI was achieved in an astounding, this is truly astounding, 10 months. 10 months they achieved their goal and payback of the system that they installed. You went from 5.4 continuous demand of megawatts of energy to 4.4. It's even been as low in more recent times as 4.2 continuous demand megawatts. That's an $800,000 savings. They were rewarded by Pacific Gas and Electric with a rebate check of $633,500. Pretty significant. Of all the 10 boilers that they had in operation before they started this energy retrofit, there are only 5 in operation today. So significant achievement. And the mayor of Milpitas actually recognized them for CO2 reduction at the same time. Probably something the mayor of my town in Indiana wouldn't think about doing, just so you know. Here's some pretty pictures. You see the little check there at the bottom, and that's Dan Burris there in the center, the facility manager receiving that big check. So good stuff. Let's move on and talk about lower operating and maintenance cost. Another cartoon for you. I like cartoons in case you haven't figured that out. Here I have to give my plug for BACnet. And this will help you answer one of those CEU credit questions, by the way. Now, for upfront design, for selection of an automation system, I really encourage you to choose BACnet over a proprietary communication method because it offers what I like to call future-proofing capabilities. For example, I'm disheartened when I hear that an entire control system is ripped out of a building to install a new control system. Yeah, sometimes in rare cases it's necessary, but a BACnet control system is always going to be interoperable. And it doesn't matter who is manufacturing it. So if you happen to lose your relationship with a particular contracting solution provider who's carrying a particular line, you can always find another BACnet provider and interoperating those systems. That's what the word interoperable means, by the way, that we're taking various products from various manufacturers and they're all speaking fairly harmoniously on this digital network that is created through this BACnet standard. There are some training-related synergies that you ought to be aware of. Training personnel is a big deal for you as a facility professional, and if you're only training them on one type of system or one front end, you're saving yourself some pain and heartache and cost. Anyway, lots of good things there. I'm running a little bit behind, so I'm going to scoot along. BACnet was also made for integration purposes, that is, for integrating systems, and that's a very sustainable thing to do. You'll hear contracting people talk about integrated project delivery, and architectural engineering community talking about integrated design. It's that system level thinking. It's that thinking that your building is part of an environment. And BACnet was really made to integrate all the systems of your building. And that can have, as indicated here, can have a very positive impact on things like transportation cost and delivery of goods to a job site. And again, significant cost on the operating budgets of buildings. Some general practices here related to operating and maintenance cost reductions. Trends and trend logs, a fairly easy thing to do. Any control system can do these things, but a trend log simply provides you data, valuable information as to what is taking place in your building. And with that data, you are enabled to make some intelligent decisions. So use that data. Make sure the trends are set up. Make sure you're using that data. And then we see just an explosion in the use of sensors in buildings. We're sensing everything these days. We're sensing more of everything these days. And that is producing more and more data, which is, maybe that's where the term big data came from. You're getting a lot of data at your fingertips. But the data can be very valuable. For example, we can put data into service professionals' hands. They can access this data remotely, become aware of problems even before you in the building become aware of a problem and address that. So this data is valuable. They can remote into your facility, or you can remote into your facility. There are wall sensors, such as the ones on the back of the room here, for example, that have data ports where a service technician can plug into it, get a bird's eye view of the entire installed system. And of course, on the energy measuring side, current sensors and power meters can help you out a great deal as well. So all those practices will save you energy, but will lower your operating and maintenance cost. Now, I pulled out a particular slide here from an online site. You see a hyperlink off to the side here. I encourage you to go there for further information. If you're interested in rooftop units, the Department of Energy has created an initiative here in conjunction with a few other parties, and there are some rebate dollars available and that sort of thing if you're not taking advantage of these kind of things. But I've provided a little chart here on when you might want to look at retrofitting a rooftop unit versus replacing a rooftop unit. But the DOE itself is estimating that these units are wasting an incredible amount of energy. Each unit between $1,000 and $3,700 a year per unit is being wasted through either ineffective control or just an ineffective, outdated unit that should be replaced. And again, there's some motivation for you to do that. Lighting systems are generally considered one of those low-hanging fruits for retrofit type purposes and for lowering your operating and maintenance costs. And I certainly encourage you to look at lighting retrofits, but I want you to do so intelligently. It's easy for an audit to take place, for example, that only considers things like the location, the type of bulbs that are being used, and the size of the space. Well, that's a fairly easy audit, but you have to examine what control, if any, is in place for these lighting systems and how it can be integrated into the rest of the system. It shouldn't be a discrete system. You're not going to get a comprehensive view of your operating and maintenance costs if you're looking at several discrete systems. So from dimming to daylight harvesting, scheduling, occupancy-based control, you can lower your operating and maintenance costs with an intelligent approach to a lighting retrofit. Another case study here, or success story if you like. This one is located actually in the country of Turkey. It's a pharmaceutical plant in the biomed arena, 400,000 square feet. They did a phased expansion and completed in the year 2012, just last year. Now here they have class 1,000 clean rooms. I forget the governing body that sets these standards, and help me out if you know, but we mentioned class 100 clean rooms for Headway Technologies. They're manufacturing a product. And that class refers to the particulate size. It has to be able to be filtered out so that it doesn't interfere with the process. Well, here's a biomed pharmaceutical place, and the particulates are even smaller. So we're talking multiple microns of particulate size here that have to be accounted for in their clean rooms. They are complying, even though it's located in Turkey, they're competing in a worldwide arena. And our domestic standard, Title 21 CFR Part 11, is governing their processes. And if you're familiar with that standard at all, you know that it's data intensive. It requires a lot of reporting. And they needed to add some mechanical systems and control, once again, without disrupting what was taking place in terms of the purpose of the facility. They added air handling units, variable frequency drives, very specialized filters, a lot of backnet sensors, a lot of backnet controllers, an advanced operator workstation to feed all this data up to a nice dashboard so that they could get a comprehensive view of their system. Now, I know this is death by PowerPoint. I'll read it to you so you don't have to. But I thought the words of these facility professionals were important. The general manager of the facility: the system has allowed the facility to operate at peak efficiency because we know we have a problem with our controlled environment long before it is out of tolerance. They don't want it to reach out of tolerance because then it's too late. They have to throw out product. This allows my facility staff to take corrective action before we lose any production. The reliability of the control system is unbelievable. We actually took out an earlier industrial process control system in one area of the plant because Company X proved they could control the space within tolerance, twice the tolerance of the old system. And he concludes that with, which translates to a lot of money. In another area, he says, we now set the alarm at 21% because that gives us an hour to address the issue before we have to shut down. As a result, our planned breakage was reduced. They actually plan for problems and throwing out things, and they've been able to plan for less and achieve less, save some cost by installing an intelligent control system. Let's talk about air quality. I just realized I have 2 more sessions to finish in 20 minutes, or 10. Another cartoon. I love this one because, hey, I made this one. So you got to laugh at this one. Oh, that's cute. I get it. He said IAQ, not IQ. Okay. Here's the question for you. Can we achieve, it's easy to achieve, by the way, indoor air quality. But can we achieve indoor air quality while maintaining the cost, without sacrificing cost? It's easy to achieve occupant comfort, but it's traditionally been a very costly thing to achieve. We over-condition a space. We over-ventilate a space to make sure people have plenty of breathable air, but that's a very costly practice. So the difference that I have noted is not necessarily related to the products that are installed. It's related to the design of the control system and the installation of the control system. So if you have a good contracting partner that you're working with, keep them. They're a treasure, and they know what they're doing. I have given you a hyperlink here to a document that we produced in BACnet International on qualifying your controls provider. It's simply a PDF file, and if you have, just because it's on this jump drive and not on the hard drive you're looking at, but it's right there. So it just asks you to answer various questions mostly related to what you want to achieve in your building, what you want to be able to control, what you're going to call them back for, what you want them to do, etc. But it's a handy little one-page front side of one sheet of paper document. If you'd like a copy of that document, by the way, grab one of my business cards here at the end, and I'd be happy to email it to you, or drop one of yours off with a note, email me the paper, and I certainly will. Demand control ventilation is getting a lot of attention these days. Now, what do we mean by demand control ventilation? Historically, we looked at ASHRAE Standard 62 for ventilation. ASHRAE, by the way, is a standard setting body, but these standards translate into codes, regulatory codes, local, regional, statewide codes that have to be enforced. And that was always based on what was assumed to be the occupancy of a building, based on the type of building it was, its size, the number of occupants that were projected to be in it at any one time. Demand control ventilation says, what we really ought to do is measure CO2. So they're sensing CO2, particularly in the return air out of a space, and determining then the proper amount of ventilation that should be brought into that space. And there's a great deal of money that you can save when you're only conditioning that required air versus everything. By the way, I mentioned ASHRAE standards, and you should note that they are changing. Traditionally, these three, and you're probably most familiar with ASHRAE 90.1. It's the standard that addresses energy efficiency. But ASHRAE itself is changing its standards, moving toward a comprehensive standard called 189.1. It's really a mirror, if you're familiar with LEED at all, to a great extent of what's happening in LEED. But it's a comprehensive view of the building. It's addressing all the comfort things, the ventilation things, the energy-related things that a building is all about. Indoor air quality is, in terms of, we're talking about comfort, for example. We always look at temperature, humidity, airflow, all contribute to those kind of things. We have to measure carbon dioxide or other pollutants to make sure we have the fresh ventilation in the system. A control system can also manage a smoke, this particular type of control, sub-control system known as a smoke control system, to keep building occupants safe in the event of a fire, and controlling smoke and keeping zones clear for evacuation. Another success story here. This one is really a showcase piece up in Seattle. It was opened just earlier this year on Earth Day. It's a commercial office building, 6 stories high, 50,000 square feet, known as the Bullitt Center. Now, oh, by the way, that's the architectural rendering, and this is what it looked like on Earth Day when they opened the building, and a dreary day in Seattle. So this is what I love that, architectural, and okay. In any event, this was billed as the greenest and most energy efficient office building in the world. It was the first commercial building in the U.S. to meet the requirements of the International Living Building Challenge. So a very significant achievement for this facility. Here's some characteristics. Have a very low leakage shell. The shell of the building is designed to be tight. Large, smart windows. Forest, what's that? Forest certified. I forget what the S. Who knows? Yeah. Yeah, what's it stand for? The S stands for? I forget. It doesn't matter. But these are certified wood products used in construction and many repurposed, quite frankly. Rainwater collection. Yes?
FSC is really about maintaining a sustainable forest for harvesting.
Correct.
As well as for harvesting.
Yeah, so when you're using wood, there's somebody along that line of people involved is replanting, for example, where trees were taken down. So they are following all the rules related to a sustainable forest.
It also includes the formaldehyde required.
Formaldehyde. Excellent. Thank you. You might think it's contrary to indoor air quality, but they use composting toilets on site. They have a 14,000 square foot photovoltaic system on the roof, and they also have a green roof. From a mechanical perspective, there's just a fair amount of backnet control used in this system. There's some traditional things taking place like air handling units and VAVs, but they have got ground source heat pumps. They got radiant heating and floor cooling in the floor. Smart windows, lots and lots of sensors, and of course a dashboard because it's a showcase facility. They have to illustrate to their occupants and the community what they're doing. There's a few pictures of, that's the central staircase. Here's a portion of a green roof, again on an overcast day in Seattle. And the sexiest part of a building, of course, is the control panel. Had to show you that. Finally, let's talk about occupant productivity and comfort. Your smartphone has undoubtedly made you more productive, right? Yeah, sure. Okay. Here are a few rules of thumb that I used in creating this section. Automation and control contributes to comfort. Comfort is linked to productivity. Sustainable practices are linked to productivity. So let's talk about sustainable practices that are closely tied to automation and control. Daylighting. We see an increasing use of glass windows in a new building. So daylighting refers to natural lighting from the outdoor as opposed to artificial lighting indoors. And it contributes greatly to productivity. Study after study, from school children to office workers, illustrate this. And if you have a better view, you have better productivity. Now, there's also a caveat here. You can't have a lot of glare because that can lower your productivity, and you have to be aware that a lot of glass in building creates a lot of heat load for the building, which has subsequent interface to the heating and cooling system. So you have to be careful. It has to be done very intelligently, but generally speaking, the use of glass is an architectural trend that is gaining a lot of momentum, and it will continue. Daylight harvesting refers to this notion that we're going to offset the need for interior lighting but with the natural or daylighting. And we're accommodating that dynamically. So as the sun moves in the sky or as the clouds move into the area, we can adjust the the unnatural lighting for the increase or decrease in natural lighting. And you need a lot of sensors to do that. You certainly need schedules to do that. And you certainly need automated control to accomplish that. Comfort. When we talk about comfort, we're really talking about three things: ventilation, temperature, humidity. All of those things require control. If we give users any amount of control of those factors, there's an automatic increase in satisfaction. So for underfloor air distribution systems, for example, we give them adjustable diffusers right on the floor, right beneath their office space, and those occupants are a lot more productive and a lot more satisfied controlling their own space. Sick building syndrome, I don't think we need to dwell on. You should note that cases of asthma, respiratory infections are at an all-time high in today's world. You should do whatever you can to mitigate those things through proper indoor air quality measurement practices. All right, case study for occupant comfort and productivity. This is a healthcare facility in Grand Traverse County, Michigan, a retrofit, a 1999 construction, but the owners were displeased. They were receiving a lot of comfort complaints from the residents, and they were not pleased with the performance of the building from an energy perspective. And so they approached this challenge, but truly with the motivation of taking better care of their residents. The facility is in a pastoral setting there in this county. It is home to about 300 residents, most of whom are have Alzheimer's or dementia of some sort. And so that was their primary motivation. How do we best care for these people? So they were looking to improve both operational performance, but the comfort of their things. They performed an audit. They revealed some things that they could address fairly easily and some things that required a little more thought. The solution was they left in place the control system that was there, but they integrated it to the a new portion that was backnet control. They repiped and resequenced radiant ceiling panels to the VAV boxes. They replaced an aged chiller and brought the new chiller under backnet control. They installed a web portal for the facility people to use. And the results, this is look at the bottom quote here from the Director of Environmental Services, Dr. Robert Seichman. The leading edge control enables us to maintain an environment where the level of care can excel. That's their motivation. Let's see how well you did on your learning objectives. I'm going to ask you true and false questions. I want you to shout out true or false. An interoperable control system, such as one based on BACnet, can help lower operating and maintenance costs. Who said that? Demerit. Okay. Adding schedules to mechanical equipment control is a good way to increase energy efficiency. Choosing an open protocol approach to building automation, such as BACnet, can help you future-proof your facility. And in the lead rating systems, the sustainable sites category offers the most potential for points related to building automation systems. I didn't talk about it, but you're right, it's false. All right, well, folks, we're out of time. Are there any general questions that we can answer real quickly? But we're right on time to conclude this session. Yes, sir.
What's your assessment of the reliability of all these sensors? Because you put in a whole bunch of sensors and they start breaking.
Are the wireless ones you're talking about in particular, or are they wired sensors?
Combination, but it's like CO2 sensors that go out of calibration, you have to make them sniff the air.
Yeah, there are hybrid CO2 sensors available today that have basically two different types of calibration methods built in, kind of a redundancy system, if you will. So those are good, a little more costly, obviously, than the standard. Yes, for CO2 sensors, you have to be careful of calibration. No way around it. Thanks much. Fill out your evaluations. Absolutely. I will send it to you. Sure.